One of the really interesting things that can be done with raster data is to make 3D models with it. And that is what you're going to be doing in the project as well. I will give you a set of data, which is called a digital surface model, sometimes called a digital elevation model, depending on what country you are in and what particular field you are in. Digital surface model and digital elevation model can mean slightly different things. It's not really important for our purposes. The data that you have essentially are height maps that show the height of elevation in different color schemes as raster pixels. Those are then going to be analyzed to produce, firstly, a set of contours and then a hillshade, or vice versa. It doesn't really matter. Now, one of the neat things about raster data is you can create a height map and you can render it to have 3D topography, and then you can drape other rasters over it. And this is exactly what Google Earth does. So this is a screenshot of Denali from Google Earth, which is nothing more, nothing less than a three-dimensional representation of the topography with an image draped over the surface of it. Now, of course, you can put other images or other data draped over it as well. So there are lots of different things you can do, and that's what you'll be doing when you create the hillshade. But you can also do slope maps and aspect maps and vegetation maps and all sorts of really cool things. As I said before, most digital elevation models come from these raster height maps, and then this gives us the ability to extrude the topography so that we can drape other rasters on top of it. And most GIS now have the ability to do this quite effectively so that we're able to get a good visualization of what an area looks like. Now, I wanted to point out, even though this really isn't about rasters, that there is another kind of 3D data that is often used for the same purposes, and this is what's called Lidar data. Lidar data is produced essentially by what's called laser ranging, and it's done in airplanes that fly over an area or pulse or shoot laser ranging down towards the ground, producing a series of what are called returns. And they're somewhere between 1 and 5 returns. Each return will measure a different aspect of the elevation below it. The final return will typically be the raw surface of the earth. But then above it, you may get returns that will be vegetation at different layers. And 1 meter pixel can get as many as 15 pulses, so it allows for really fine quality 3D modeling of an area. It also allows you, through the creation of what's called a point cloud of data, so essentially this three-dimensional set of data that can then be modeled and manipulated, to do all sorts of really cool things with it. Not the least of which is getting a super accurate view of the surface of the Earth, but also enabling you to produce models of the vegetation that are on top of it, or to find features that may be below very dense ground vegetation or even layers of thin soil as well. It's often used in the detection of areas that might be ripe for archaeological digs, for example. These are just a couple of images that show the types of things that LiDAR can be rendered into. In the upper picture, you see a vegetation model that has been rendered using different heights, and you can actually see the shape of the spruce trees in this area. And then down below is a LiDAR image that has been rendered of Washington, D.C., where you can actually see buildings and vegetation as well. So it's pretty cool stuff. We are not going to be using it in this course, but it's certainly something that is worthy of further exploration, particularly if you are really interested in the sort of topographic things that we are dealing with in this raster project.